So we have seen that a redox reaction is a reaction that involves both oxidation and reduction. For example, you have got x, y, which goes, let's say, into x plus y. Maybe on the product, x has a charge of positive 1. On the reactant, it has a charge of negative 1. And then this one has a positive, this side it has a negative. So x, the charge is moving from from negative to positive. When something becomes more positive, that is oxidation. And then this one is moving from positive to negative. When it becomes more negative, that is the reduction. Okay, so this is a redox reaction. Now, how do you balance redox reactions using oxidation number method? Now, using oxidation number method, you need to find all the oxidation numbers in that compound, right? For example, let's say you have got hydrogen reacting with oxygen to form water. This is what you've been given. You want to balance using oxidation number method if this is a redox reaction. So, you know that for a pure element, the oxidation number is what? 0. Even this side oxygen, oxidation number is 0. Now, we know that the oxidation number for oxygen is always negative 2. The oxidation number for hydrogen is always positive 1. Actually, if you multiply 2 times positive 1, that will give you positive 2 minus 2, it will give you 0. You expect that water should have a charge of 0 because it's not charged, right? So here what you have is hydrogen is moving from 0 to positive 1, right? And then oxygen is moving from 0 to negative 2. So what you do for this method is, when you are moving from 0 to positive 1, is that oxidation or reduction? It's oxidation. And if you find the change in oxidation number, on the product, hydrogen has the oxidation number of positive 1, right? Minus, on the reactant, it has got an oxidation number of 0. So positive 1 minus 0 is just a 1, meaning that only one electron. Remember, oxidation has to do with the loss of electrons. So you need to show that one electron is lost. And then if you look at oxygen, you're moving from 0 to negative 2. You know, when something becomes more negative, that is reduction. If you find also the oxidation number difference, on the product you've got negative 2 minus, on the reactant you've got 0. Negative 2 minus 0 is simply negative 2, meaning that 2 electrons have been gained. Why? Because that is reduction. Or if you find the difference in oxidation number, you find that your answer is negative, just know that electrons have been gained. Okay, if you find it positive, just know that electrons have been lost. Now, from here, what you do is you are going to swap these numbers when you are using oxidation number method. This reaction has 2 electrons, this reaction has got 1 electron. So swap these numbers, multiply this reaction by 2, which is coming from here, and then multiply this reaction by 1, which is coming from here. Okay, so what are you going to have? You are going to have 2 multiplied by hydrogen, that is supposed to give you, have I already swapped them? Okay, we're supposed to swap them like that. So if we do the multiplication, we are going to have a 2 here, and we're also going to have a 2 here. That is what we are going to have, right? So let me do that. 2 hydrogen. Okay, if you multiply this other like by a 1, you'll not, there will be no difference. Now notice that since we have got one product only, since you only have one product, you're supposed to multiply the same equation by a 1, and the same, like this side, you're supposed to multiply by a 1 and also by a 2. So it becomes trick when you have got the same equation. So I'll say plus oxygen, since you're only multiplying by a 1, and then you go on the product 2 water molecules like that. So there's nothing else that you are going to be able to do. Like if you multiply by 1, still you multiply a 1 here and a 1 here. Nothing is going to change, right? It will just be the same. So you can see 4 hydrogens, 4 hydrogens. two auctions, two auctions. That's how you balance by this method, right? Now if it didn't balance like that, you use inspection. So you start looking at those atoms which are not balanced so that you balance by inspection. Okay, let's look at examples. You have got this question here: iron oxide plus aluminium going to iron plus aluminium oxide. Let me rewrite this on the middle. So we need to find the oxidation number of all the elements. We know oxygen, I mean aluminium, since it just alone is 0. Oxygen, we know that is always -2, right? So if we say 2 times oxidation number for iron, and then plus we have got 3 oxygens, and each oxygen the oxidation number is -2, we're supposed to get 0, right? Because the oxidation number for this compound, the total is 0, it's not charged. So this is going to give us -6. If we take the -6, that side becomes +6, and then we divide by 2, it is going to give us +3. So that is the oxidation number for iron in this compound, +3. If we go on the product, iron here is 0, oxygen is still -2, and then the oxidation number for aluminium, we want to find it, plus we have got 3 oxygens, and this oxygen is -2. This is supposed to give us 0 because this compound is not charged. So 3 times -2 is -6. It goes the other side, +6. You divide by 2 to be +3. So that's the oxidation number for aluminium. And then we'll put it on top. So those elements whose oxidation number is changing, you are going to put arrows. Iron, the oxidation number is changing. So it is moving from +3 to -3. So if you find the oxidation number difference on the product, you've got 0. Yes. So on the product you've got 0, minus on the reactant you've got a +3. If you subtract, you are going to get -3. Remember we said if you find a negative change in oxidation number, then that is what? So 3 electrons, okay? Yes. So 3 electrons have been gained because you have a, like, oxidation number is reducing from 3 to 0, that is reducing. And when you've got oxidation number reducing, that is reduction, and reduction is gain. So 3 electrons have been gained. And then from oxygen, you are going to also another oxygen here. Now for this one, you can see actually there is no change because it was -2 to -2, so there is no change. And then from here I've got 0 to +3. Okay, so if you consider that one, what is happening? You have from 0 to +3, there is an increase in oxidation number, and 3 electrons then have been lost because there is an increase. Now since it's the same number of electrons which have been lost and gained, meaning that you're supposed to multiply this by 3, also this by 3, and that will cause no difference because it's the same thing. Okay, so meaning that for this one, just in this state that it is supposed to be like it is balanced. So what you're supposed to do is swap the numbers as you've seen, multiply the first reaction by 3, the other one also by 3. So we're going to multiply this one by 3, it's going to have a 3 here, also a 3 here. And then multiply also the other one by 3, supposed to have a 3 here, also a 3 here. Now notice that if you do that, the atoms are not going to be balanced. So in a case like this one, you have got the same number. You are supposed to multiply this by 3, also this by 3, but notice that there is already a number down here, alright? And then there is no number there. So if you already have a number down, in such a case, what you do is balance by inspection, alright? By inspection. So you can already see that this is 1, I mean these are 2, this is 1. So by inspection is just put, you're supposed to multiply by 3 here, also by 3 here, but because there is already a 2 here, that means that you are supposed to multiply also this number by 2, so it becomes a 6. Okay, also this one, You're supposed to multiply by 3, also by 3, but because there's already a 3 here, supposed to multiply this one by, I mean there's already a 2, you're supposed to multiply this one by 2, so it becomes a 6, like that. Now since the 3 is common, you can divide, so meaning that to balance you could have just put a 2 here and a 2 here. Is that okay?
Yes, sir.
Let's consider this one. Is it's the same question, ion. Okay, it's the same one. Let's consider this one. So the oxidation number for oxygen is negative 2. Since this one doesn't have any charge, that means that carbon should be
Sir,
positive.
to show you're working down to.
Yes, we need to show how the electrons are moving. Like if you don't show, you lose marks. And then oxygen, we know that is negative 3. And I think we already calculated, we found, oh, sorry, negative 2. We found that iron is going to be positive 3. And then oxygen here is negative 2. So 2 times negative 2 is negative 4. You take the negative 4, the other side becomes positive 4 because the charge is supposed to add up to 0. So ion here is 0. So ion, the oxidation number is moving from positive 3 to 0. It's becoming less positive, meaning that's reduction. So 3 electrons have been gained because reduction is gain. Oxygen, the oxidation on the reactant, you have got negative 2, even when the product is negative 2, so it's not changing. But carbon is changing from positive 2 to positive 4. If you find the difference, 4 minus 2, that is a positive 2. And it is becoming more positive. That means that 2 electrons have been lost because an increase in oxidation number is oxidation. So you are supposed to swap these two numbers, meaning that this reaction multiplied by 2, this reaction multiplied by 3. So you need to be showing this as you are working out your questions. So if you multiply this by 2, you are going to have 2 ion, 2 oxygen, like that, plus this other one I'm multiplying by 3, so 3 like that. And then the ion is supposed to multiply it by 2, 2 ion, okay, and then plus this other, the carbon dioxide, is supposed to multiply by 3, so that will be 3 carbon dioxide. After you do this, now what remains is now balanced by inspection. So you just be looking at those atoms which are not balanced. That's by inspection. You can see we have got we already had a 2 here. That means that this one is supposed to be multiplied by again by a 2, so to give us a 4, right? So this one is supposed to multiply by a 3, by a 2. By inspection, we are supposed to put a 4 there. We'll rewrite that. And then oxygen, we have got 3 here, plus this 3, that is 6. And then we have got 6 there. Carbon, we have got 3, carbon, we have got 3. So that means the reaction is now balanced. Is that okay? Is that okay?
Sir,
Yes.
yes. Okay, I wanted to ask you another question now. You said that you multiply it with the two since we have found two on the other side, right?
The 2 which is down, yes. Okay. Let's have another one. Let's say you have got aluminium. Let me write it on the middle. You have got aluminium which is reacting with sulfuric acid to produce aluminium sulfate, and hydrogen gas. You want to balance this one by the ion electron method. So what you are going to do, aluminium, the oxidation number is 0. Oxygen, of course, is negative 2. Hydrogen is positive 1. So we need to find the oxidation number for sulfur. So I've got 2 hydrogens times the positive 1, so that will be positive 2, we have got 4 oxygens times the negative 2, that will be negative 8, plus sulfur, the oxidation number for sulfur, we are supposed to get 0. So 2 minus 8, that's a negative 6. You take it the other side, that will be positive 6. That's the oxidation number for sulfur. The other side of the equation, hydrogen is going to be 0. Still oxygen is negative 2. We know that aluminum is positive 3. The sulfur, we can calculate its oxidation number. But we can, even if we want, we can just use a sulfate. The oxidation number for we know that a sulfate has got a charge of negative 2. So the oxidation number for sulfur plus 4 oxygens, and each has a negative 2, should give us negative 2, which is the charge on top. So 4 times negative 2 is positive 8. To take it the other side, that will give you positive 6. So the oxidation number for sulfur is not changing. So you look at those which are changing. Aluminium is moving from 0 to positive 3. And then hydrogen is moving from positive 1 to 0. Oxygen is not also changing. So since it's moving from 0 to 3 and it's becoming more positive, meaning that 3 electrons have been lost, because that is the oxidation. Then from positive 1 to 0, that means that 1 electron is gained. So you are going to swap. Multiply this reaction by 3, multiply this by 1. Okay, so if you multiply this by 1, you are going to have aluminium, and then here you are going to still have the aluminium sulfate. Then multiply the other one by 3, you are going to have 3 sulfuric acid, and then you are going to have here 3 hydrogen molecules. Yes.
So aluminium from 0 to positive 3 is gaining electrons.
When something becomes positive, is that oxidation or reduction?
It's reduction.
You've just, you've
Oxidation.
already forgotten.
No, I haven't forgotten.
Okay.
It's oxidation.
Yeah.
More of oxidation.
Yes. So now after you do this, you now balance by inspection. So you can see we have got 6 hydrogens, and then you have got 3 sulfates, 3 sulfates. But aluminium, you have got 1 on the reactant, 2 on the product. So simply put a 2 here. Then you have balanced by by oxidation number method.